5, inequalities in two triangles. All right, investigate the side and angle relationship. Exercise 1, as a rider pedals a unicycle, how do the measures of angle A and the length of B change? What does this suggest about the change in the triangle? Okay, so we can see that as our measure of angle A is increasing, our side B is also increasing. Okay, so if our other two sides are staying the same, then our angle will increase. All right, our try it. Compare the measures of angle J and the side lengths of K for the triangles. Okay, so we can see that as our triangle is changing from acute to obtuse to right, our side lengths are increasing, or from acute to right to obtuse, I guess I should say. Okay, so as our angle is getting larger, our side length is also getting larger and increasing. Okay, our hinge theorem. So our hinge theorem, if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. Okay, so for that, we have two sides that are congruent. So we've got our congruent side 1 and then congruent side 2. And this is telling us basically that our larger third side, so that whichever triangle has a larger side is going to be the opposite the one with the larger angle. So our W here would be larger because our XY is the larger side. All right, applying the hinge theorem. The tension in the exercise band varies proportionally with the stretch distance. The tension T is described by the function T times X equals K times X, where K is a constant that depends on the elasticity of the band and X is the stretch distance. Which position shown in the figures has a greater tension in the band? Okay, so we know that the angles opposite our sides are 80 and 50. The 80 is larger, so that means that our side K, or MK would be larger than LK because 80 is larger than 50. Okay, we've got our function T times X equals K times X. I want to isolate this for X, so I want to get rid of this K by dividing. So I'm left with T times X divided by K equals X. So I've isolated X. Okay, I know that MK, my MK, this is X and this is X. So my MK is X, so I'm going to plug in MK for X, so I would have T times MK divided by K is greater than my LK, which is X, so T times LK divided by K. Okay, well my K's cancel each other out, so I'm left with T times MK is greater than T times LK. Okay, so my tension is going to be greater the farther the person is pulling up on the band. Try it. The man keeps his arms extended and the length of the tension band the same. If he wants to make the measure of angle L smaller, how should JK change? Okay, in order to make the measure of angle 3 smaller, we would have to make the measure of angle 3 decrease. Which means that the length of JK would decrease. And essentially, he would be squatting down to decrease his height. All right, our converse of the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle opposite the longer third side. Okay, so now we're looking at angles instead of the sides. All right, so example 3, we want to prove that the measure of angle FDE is greater than the measure of angle VTU. So they told us that DF is congruent to TV and DE is congruent to E. Okay, this should not say EF. So DE should be congruent to TU. So that's got an error in it. Should be TU. Okay, and then EF is greater than UV. Okay, so we're gonna work on our proof, statements and reasons. Okay, so we're going to prove the opposite of what we're going to start with the opposite of what we're trying to prove. So we're going to start with the measure of angle FDE is less than the measure of angle VTU. And we're going to do that through an assumption. Okay, it could be less than or equal. Okay, and if it's possible that it could be equal, then we would be able to prove our triangles are congruent. So triangle DEF would be congruent to triangle TUV. That would be through side angle side, because we have a side, an angle, and a side. And then if we know that the triangles are congruent, then we would be able to say that EF is congruent to UV through corresponding parts of congruent triangles are congruent. Okay, and based on that, if we're able to prove that EF is congruent to UV, then EF could not be larger than UV. our triet. Do another proof. Okay, so we're trying to prove that we lead to a contradiction that EF is greater than UV. So we're going to start with our assumption that EF is equal to UV. And if EF is equal to UV, that means that triangle DEF would be congruent to triangle TUV by side, side, side. And if our two triangles are congruent, that means our two angles would be congruent. So the measure of angle FDE would be congruent to the measure of angle VTU. Through corresponding parts of congruent triangles are congruent. All right, example 4, what are the possible values of x? Okay, so let's use the information that we know. So we know our 14 is smaller than the 18, so our FG is less than CD, which means our angle FEG would be smaller than our angle DEC. Now I'll plug in the information that I know for those. So I know that angle FEG is 36 degrees and DEC is 2x minus 4. And I'm going to solve for this. Okay, so our x has to be greater than 20. Okay, we also know that we have another side that is opposite those two sides that are congruent. So CD is 21 is less than AB. So then angle DEC would be less than angle ACB. Now I can plug in what I know. I know DCE is the 2x minus 4, and my ACB is 60 degrees. Now I'll solve for x. So x would be less than 32. Put all of these together, so 20 is less than x, and x is less than 32. So that means my x has to be somewhere between 20 and 32. All right, what are the possible values of x for the diagram? Okay, so for this one, they only gave us 2 in this set, but we know that our angle can't be less than 0 for our second choice. So our smallest has to be greater than 0. We've got our 4x minus 18, which has to be less than the 54. And I'm going to work this all at once to solve. Okay, so my x has to be somewhere between 4.5 and 18. B, what are the possible values of x Okay, so I know that these two sides are congruent through the reflexive property. Okay, so because our x is opposite the larger of the two sides, I don't need to find a smaller option. So for this one, I would have that 32 is less than my 3x plus 5, and I'll solve. So x needs to be larger than 9.